The James Webb Telescope has shown us where the universe ends and what lies at its edge. The discoveries have shocked scientists by challenging some of the fundamental laws of physics. How big is the universe really? And will we ever know everything about our cosmos? Let's delve into the vast expanse of the universe together now and solve the mystery of its true size. An infinite cosmos? Ever since we humans have been able to look out into space, we have wondered how big is our universe really? Does it have an end, or is it infinite? For centuries, there was hardly an answer to this question. 100 years ago, researchers claimed to have found evidence that the cosmos originated from a temporal starting point. Since then, we know this as the Big Bang. But now, the James Webb Telescope turns this assumption and many other cosmological principles on their head. We are now looking further back in time than ever before. Up to 13.5 billion years old is the light that James Webb captures. 13.5 billion years old are the objects that once emitted the light. We can only look as far as the light lets us. If there had been a dark, initial time of the cosmos, it would elude our gaze forever. By looking back billions of years into the past now, the James Webb Telescope has given us glimpses of how the universe was formed and shown us what lies at its edge. Galaxies so old, so large, and so complexly organized that they could not possibly exist according to previous assumptions of cosmology. Yet, they are there, irrefutably and visibly for everyone to see. With the demise of the temporal beginning, also the theory of the temporal end begins to wobble. Can it really be that our cosmos has always existed and will always exist? Just as researchers must come to terms with the idea that time is a finite concept only for us humans, they must reckon with the fact that our cosmos is spatially so large that we can never find the end. Professor Saul Perlmutter. This means that the simplest picture of the universe is a universe that is infinite. We could actually live in a universe where there's galaxy after galaxy, in every direction, up, down, sideways, and it never ends. Since we humans have been exploring space with telescopes, we have been discovering limitlessness and wonder. Not only are the vastness and sizes of the universe overwhelming, but the beauty and diversity of creation can take your breath away. Now let's dive into some of the sizes of the universe that will challenge your mind. Big, bigger, infinite. Right now, scientists are surveying a space that spans some 93 billion light years, and there's no end in sight. We have to reckon with the fact that despite these enormous dimensions, we see only a small part of an incredibly big universe so far, and possibly we see a part of infinity. Let us illuminate the dimensions of 93 billion light years a little more precisely. 1 billion is a 1 with 9 zeros. 93 billion light years are already dimensions with which our mind has difficulties. To open your mind and give you insight into the true size of the universe, let's first look at what a light year even is. A light year is the distance light travels in 1 year. A single light year is equal to 63,000 astronomical units, and 1 astronomical unit is the average distance from the Earth to the Sun. Expressed in kilometers, that's 149.6 million kilometers. 149.6 million kilometers? We would have to circle the Earth at the equator about 3,729.5 times to come to a distance of 149.6 million kilometers, or simply drive from Munich to Berlin 258,069 times. And dear friends, we're here with just the cosmically seen tiny distance between the Earth and the Sun. The universe observable so far, with an extension of 93 billion light years, corresponds to 5,876,417,284 astronomical units. And thus, 5,876,417,284 times the way from the Earth to the Sun. Currently, scientists believe that the entire universe could be 250 times larger than what we can currently perceive. These estimates are based on observations and findings from modern cosmology, and in particular, the concept of the observable Hubble sphere. The observable Hubble sphere is the region of the universe that can be observed from us, since light from objects in this region has been reaching us since the Big Bang. If this estimate is correct, it means that the extended universe has a diameter of at least 23,250 trillion light-years, 1,468,820,000,000, or 219,735,750,000,000,000. Well, are your heads smoking yet? That is not our intention, because today, we want to give your mind the possibility to go beyond its limits and to imagine the universe in a completely new way. Let's go back to the now almost pleasantly manageable distance from the Earth to the Sun. A spaceship would have to fly 1,468,820,000,000 times back and forth to come to the distance which our universe probably measures in its diameter. On the way with the light. Let's move on to another refreshing quantity that will leave you amazed: light. Nothing travels through space as fast and constantly as light. To travel once from the Earth to the Sun, light particles need just 8 minutes and 20 seconds. To cross the solar system once, light needs about 21 hours and 20 minutes. The universe observable so far has an extension of 93 billion light-years. A light particle would need an unbelievable 93 billion years to travel once across. Maybe now you're beginning to understand how enormous the dimensions of our universe really are. We humans are tiny little dots in a cosmos which possesses unbelievable dimensions. For us, the Sun is just a gigantic fireball, and we've only moved once with ponderous spaceships to the Moon. Mars, with a distance of about 1.5 astronomical units, is a challenge that we can't quite master at the moment, at least not when it comes to sending humans through the cosmos. Probes, on the other hand, have been successfully flying through the solar system for many decades. They don't mind the increased radiation. They're smaller and lighter and can move quite fast. The great pioneers and heroes of space travel, which are still on the way today, are the space probes Voyager 1 and Voyager 2, launched in 1977. In the meantime, they have flown over the border of the solar system and are now just exploring the outer areas. Until they are fully in the enormous void between the star systems, still some years will pass. Currently, both are about 23 billion kilometers away from Earth. That corresponds to about 153.86 astronomical units, or 153.86 times the distance between Earth and the Sun. Both probes will take a little more than 30 years to travel to the edge of the solar system. Voyager 1 races through space at about 61,000 kilometers per hour. Although their speeds may sound impressive to us, these numbers represent only a tiny fraction of the speed of light. The nearest star system beyond our Sun is the triple system Proxima Centauri. There, the three stars Alpha Centauri A and B, as well as Proxima, perform a wonderful galactic dance. On average, the center of the three are about 4.24 light-years away from our solar system. Even if we could travel at the incredible speed of light, it would take us about 4.24 years to stop by the neighboring star system. The Voyager spacecraft, however, would take an estimated 70,000 years to travel the same distance. The difference between their speed and that of light becomes clear here, illustrating the vastness of the universe and the difficulties of interstellar travel. We are still moving here in close proximity to our own star, and yet the distances are already vast. Billions of galaxies, trillions of stars, and countless planets. Let's consider that our star system within the Milky Way is only one of an estimated several hundred billion. The nearest galaxies to both are rather small Magellanic clouds. The Large Magellanic Cloud is estimated to contain about 10 billion to 30 billion stars. The Small Magellanic Cloud has a slightly smaller number, with about 7 billion to 10 billion stars. Our nearest galactic neighbor is the Andromeda Galaxy. At 220,000 light-years across, it's nearly twice the size of the Milky Way, and experts suggest that this galaxy is home to at least 1 trillion stars. Although Andromeda is one of our closest neighbors, this galaxy is a full 2,537,000 light-years away from us. Now, we have 4 galaxies, and there are at least about 100 billion to 200 billion galaxies cavorting in the universe known so far. Again, our mind comes to its limits, and this becomes even more enormous if we imagine not only the matter, thus the stars and galaxies, but look at the interspaces, the enormous emptiness, the nothingness. Here, at the latest, it becomes clear that the exploration of the universe will still be a challenge even when humans can travel through space at the speed of faster than light. The discovery of infinity? Let us not forget, please, that nobody knows yet whether our cosmos really has an end or not. Let's go back to the latest discoveries of the James Webb Telescope. Scientists hope to use the telescope to look at the dawn of the universe, the time just after the Big Bang. What did they hope to find? Well, probably the first stars, first collections of stars, or galaxies, showing that the oldest of them were quite different from today's galaxies. But instead, researchers found galaxies that were at least as perfectly shaped as today's. Spirals, disk, or spherical galaxies seem to have existed more than 13.5 billion years ago. The temporal beginning of the universe is since then on the test stand. To be precise, researchers have so far found no evidence in the oldest light traces that the universe is somehow tapering off, as it would be to look at the lifespan of a chicken, to a chick, to an egg. It almost seems as if the universe has always been the way it looks now. Now that you have a little better picture of the vast expanses of space, you can much better imagine how difficult it is for scientists to survey and measure a space of this size and put directions of motion and dynamics into a coherent context. These attempts are like an ant using a calculator to examine a gigantic skyscraper building. But what do you think now? Does it make any sense at all to search for an end and a beginning of the cosmos? And can you imagine an infinite universe?